Okay, let's cover 4.6. We need to talk about the ways to solve quadratic equations, and let's review the ways we already have. We all like to do the factoring, okay? And so basically that's useful when it's easily factorable. So I would say this is sometimes helpful. Another way we can do this is by square root both sides, right? So when you extract square roots. So that's helpful in a situation like this. So I can easily square root both sides. So that's also sometimes helpful. We talked about you can always solve it by graphing on your calculator. I don't think I'm going to list that here. But we talked yesterday about completing the square. And that was difficult. But the good thing about it is it always will work, right? Doesn't have to be factorable, right? And you don't have to have this perfect square already set up for you. So it's a difficult method to use, but it will always work for you. And what we're going to work on today, of course, is the last method we're going to talk about is just using the quadratic formula. And what is wonderful about this quadratic formula is the fact that it will always work, and it's never very tedious, okay? So when in doubt, if you see a quadratic and you're not quite sure how to solve it, just go ahead and do it by a quadratic formula. Okay, so what exactly are we talking about quadratic formula? Remember, you have to start with something in standard form. So ax squared plus bx plus c is equal to 0. Okay, and then if you have that set up, then you can find the value of x is equal to, and this is the part so many of you all forget to write down, is x is equal to minus b plus or minus square root b squared minus 4ac all over 2a, which of course you will memorize. Now, this formula did not just fall out of the sky, but I will show you how to derive it, and you will be able to do it yourself. We'll do it in class, okay? So it's a wonderful exercise, and you'll be able to do it. That's sort of a hint too. Okay, so let's talk about this. We're going to find the values that make this quadratic expression equal to 0. What'd you forget, Will?
My bag.
Oh, okay.
I'm still packing. I'm about to leave though.
Okay.
Oh, what is that fine?
Oh, okay. Anyways, you all know how to use this. Let's just try one. So let's say I had an example, and maybe I'll even just let you do it. X squared plus 5x. Bye, Will. Have a good time. Shoot 'em up. Is equal to 0. All right. Pause it if you want to do it yourself. Otherwise, I'm going to just keep going. Of course, I have my a equal 1, b equal 5, and c equals 6. I don't even have to worry about negative numbers. So I'll go ahead and say x is equal to minus 5 plus or minus the square root of 5 squared minus 4 times a times 6 all over 2a. Nope, but a was 1, so let me put a 1 here for a. Alright, then it's a matter of simplifying following PEMDAS, and here's where maybe some people get in trouble. We do not use a calculator to evaluate this quadratic formula. Maybe you've done that in the past, done it all on your calculator, but no. It's order of operations. So minus 5 plus or minus square root of 25 minus 24. Oh, this is going to be sweet. All over 2. Let me just continue it. X is equal to, and notice I'm never losing my x is equal to. X is equal to minus 5 plus or minus the square root. I got 25 minus 24, which is 1, and the square root of 1 is 1, so I have 1 right here, all over 2. So of course now I need my little t-chart where I have minus 5 plus 1 over 2, or x is equal to minus 5 minus 1 over 2. So Going on up, x is equal to negative 4 over 2 or negative 2, or x is equal to negative 6 over 2, negative 3. So I get my two answers. Okay? Sure. Could you have done this one by factoring? Of course you could have. Okay, of course the quadratic formula is most helpful when things don't factor nicely, typically here like when you have irrational roots. So we could try one like that, do it a little differently. Let's try 3x squared plus 5x plus is equal to a negative 1. Okay, now what's the first thing you have to do? You remember, you have to have the equal 0 for the standard form. So we've got to make sure we have that equal 0 first. 3x squared plus 5x plus 1 equals 0. Now find your a, b, and c. I'll let you work it out. Okay, working it up, working through your PEMDAS, you end up with this expression right here. X is equal to all of that, and you can't simplify this any further. You can't write it. There's no better way to write this. The plus or minus can't be kind of split up and figured out one way or the other, so we're going to leave it alone. But I do want to bring up one point, and that's sometimes it happens when you're working on a problem like this, that you end up with x is equal to, let's say we'd done minus 5 plus or minus 10 square roots of 3 all over 5. Okay, and the question is, how do you reduce that into simplest form? And the way to think about it is, both of these terms, this is a term here, and this is a term here because they are separated by addition or subtraction. Okay, so they're both two terms, but both of those terms are being divided by the 5 underneath here, right? So this one gets divided by 5 minus 1. And then this one also gets divided by the 5, plus or minus 2 square root of 3. So there are your two examples for values of x. Alright, here's a vocabulary word for us called the discriminant. And the discriminant is a helpful piece of information because it tells us about the characteristics of the root. So first let's discover what is the discriminant. If you wrote down the entire quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a, the discriminant is lurking inside this little piece of it right here. Okay? Because that holds the key. So the discriminant is equal to b squared minus 4ac. So not anything new to remember, just it's that piece of it. Well, what does the discriminant tell us? So, let's see. If the discriminant is 0, let's talk about that first of all. Because then you have x is equal to this minus b plus or minus the square root of 0 all over 2a. But wait a minute, the square root of 0 is just 0, and it doesn't matter if you add or subtract a 0? No, so it's just minus b over 2a. The question would be, how many solutions? Figured out there's only one. Okay? So in all these other problems we've been working on so far, you know, the plus gave us one solution and the minus gave us the other solution. In the quadratic formula we always had two solutions. But every once in a while it happens where this discriminant is 0, and so there is only one solution. Okay? So that's one thing that can happen. Okay, so another thing that can happen is if the discriminant is not 0, that this time it's less than 0. So then you're looking at taking x equal minus b plus or minus the square root of a negative number all over 2a. So you know that the square root of a negative leads to imaginary numbers. So you will have imaginary solutions for x, or you could say you have imaginary roots, and there will be 2 of them. Okay? So when that discriminant is less than 0, 2 imaginary roots, and the case we've been looking at before that you saw when the discriminant was greater than 0, then, as we've been seeing before, we had 2 real roots. That's sort of the typical case that we've been doing before. Alright, so let's talk about these graphically. So, and you're looking at a graph, what does it mean when the discriminant is equal to 0 and you have one, and it will be real, one real root? That means your graph, now I don't know if it's up or down, but it has one x-intercept. So it comes like that, okay? So it could be anywhere, or it could open down. But the point is it touches that x-axis in exactly one place, because remember, the roots of a solution, roots of that equation, are the same as the x-intercepts. So that's one example. The other example was when d was less than 0, and you had those two imaginary roots. What does it look like graphically? We go here, and then the graph with no real roots, that it has no x-intercepts, so it's got to do something like this. Well, you know, it's above the x-axis, or if it had open down, where it's below the x-axis. Okay? And then finally, we had talked about when the discriminant is greater than 0, you have two real roots, so you have two x-intercepts, x and y-axis, and then you draw your graph like this, or perhaps it's upside down, we don't know. Okay, so if you can tell me just about the discriminant, you'd have to go through the whole quadratic formula. You can tell me about the number of x-intercepts and basically what the graph would look like.